Today we are going to discuss some of the problems on inverse Z transform using partial fraction method and power series expansion method. First problem, find the discrete time sequence x of n which has Z transform x of z is equal to minus 1 plus phi z inverse divided by 1 minus 3 by 2 z inverse plus half z to the power minus 2 with ROC mod z is greater than 1. It is given x of z is equal to minus 1 plus phi z inverse divided by 1 minus 3 by 2 z inverse plus half z to the power minus 2, or we can write it as minus 1 plus phi z inverse divided by 1 minus half z inverse into 1 minus z inverse. Here m is equal to 1, that is numerator highest power, and n is equal to 2, denominator highest power, that is m is less than n. Therefore, we can expand x of z using partial fraction, that is x of z is equal to k1 divided by 1 minus half z inverse plus k2 divided by 1 minus z inverse, or k1 is equal to 1 minus half z inverse into x of z at z is equal to half, which is equal to 1 minus half z inverse into x of z is minus 1 plus phi z inverse divided by 1 minus half z inverse into 1 minus z inverse. This 1 minus half z inverse, 1 minus half z inverse cancels. Then the remaining terms are minus 1 plus phi z inverse divided by 1 minus z inverse at z is equal to half. You have to find out. So it is minus 1 plus 5 into 2, because z is half, z inverse is 2, divided by 1 minus 2, which is equal to minus 1 plus 10 divided by minus 1, which is equal to minus 9. Similarly, k2 is equal to 1 minus z inverse into x of z at z is equal to 1. 1 minus z inverse into x of z is minus 1 plus phi z inverse divided by 1 minus half z inverse into 1 minus z inverse at z is equal to 1. This 1 minus z inverse, 1 minus z inverse cancels. Remaining term k2 is equal to minus 1 plus phi z inverse divided by 1 minus half z inverse at z is equal to 1, which is equal to minus 1 plus 5 divided by 1 minus half, which is equal to 8. Therefore, x of z is equal to minus 9 divided by 1 minus half z inverse plus 8 divided by 1 minus z inverse. and we have x of z which has ROC, small z is greater than 1, that means it exists outside the circle of radius 1 or outside the unit circle. Therefore, the discrete time sequence corresponding to both the terms in the above equation must be right-sided. And by taking inverse Z transform and referring the table explained in the theory part, we get x of n is equal to minus 9 into half to the power n into u of n plus 8 into u of n, or x of n is equal to minus 9 into half to the power n plus 8 into u of n. Next problem, find the inverse Z transform of the signal x of z is equal to 1 plus 2 z inverse plus z to the power minus 2 divided by 1 minus 3 by 2 z inverse plus half z to the power minus 2 with ROC mod z is greater than 1 using partial fraction expansion method. It is given x of z is equal to 1 plus 2 z inverse plus z to the power minus 2 divided by 1 minus 3 by 2 z inverse plus half z to the power minus 2, which is equal to 1 plus 2 z inverse plus z to the power minus 2 divided by 1 minus half z inverse into 1 minus z inverse. Here m is equal to 2 and n is equal to 2. That means m is not less than n. So we have to use long division method, that is half z to the power minus 2 minus 3 by 2 z inverse plus 1 z to the power minus 2 plus 2 z inverse plus 1. So if I multiply by 2 times, I will get z to the power minus 2 minus 3 z inverse plus 2. So 5 z inverse minus 1, or x of z is equal to 2 plus 5 z inverse minus 1 divided by 1 minus half z inverse into 1 minus z inverse. So we can consider these two terms as x1 of z. Now we can apply the partial fraction expansion for this term, second term of the above equation. Then x1 of z is equal to 5 z inverse minus 1 divided by 1 minus z inverse into 1 minus half z inverse, or x1 of z is equal to k1 divided by 1 minus half z inverse, or you can take 1 minus z inverse also, plus k2 divided by 1 minus z inverse, or k1 is equal to 1 minus half z inverse into x1 of z at z is equal to half, that is 5 z inverse minus 1 divided by 1 minus z inverse at z is equal to half. We get the answer as minus 9. Similarly, k2 is equal to 1 minus z inverse into x1 of z at z is equal to 1, which is equal to 5 z inverse minus 1 divided by 1 minus half z inverse at z is equal to 1, which is equal to 8. Therefore, x of z is equal to 2 plus minus 9 divided by 1 minus half z inverse plus 8 divided by 1 minus z inverse. Since ROC exists outside the circle of radius 1, then x of n must be right-sided sequence, and using linearity property, because we have 2 plus no linearity property, we get x of n is equal to 2 into delta of n minus 9 into half to the power n into u of n plus 8 into u of n, or x of n is equal to 2 into delta of n minus 9 into half to the power n minus 8 into u of n. Next problem, find the inverse z transform of x of z is equal to z square minus 3z divided by z square plus 3 by 2z minus 1. With the ROC given, half is less than mod z less than 2. It is given x of z is z square minus 3z divided by z square plus 3 by 2z minus 1. Multiplying both numerator and denominator by z to the power minus 2, we get x of z is equal to 1 minus 3z inverse divided by 1 plus 3 by 2 z inverse minus z to the power minus 2, which is equal to 1 minus 3 z inverse divided by 1 plus 2 z inverse into 1 minus half z inverse. Here m is equal to 1, n is equal to 2, that is m is less than n. So directly we can do the partial fraction. Therefore x of z is equal to k1 divided by 1 plus 2z inverse plus k2 divided by 1 minus half z inverse, or x of z is equal to 1 plus 2z inverse into x of z at z is equal to minus 2, which is equal to 1 minus 3 z inverse divided by 1 minus half z inverse at z is equal to minus 2, which is equal to 2. Similarly, K2 is equal to 1 minus half z inverse into x of z at z is equal to half, which is equal to 1 minus 3 z inverse divided by 1 plus 2 z inverse at z is equal to half, which is equal to minus 1. Therefore, x of z is equal to 2 divided by 1 plus 2 z inverse plus minus 1 divided by 1 minus half z inverse. Since ROC half less than mod z less than 2, then the corresponding x of n must be two-sided. Taking inverse the transform and referring the table, we get x of n is equal to minus 2 into minus 2 to the power n into e of minus n minus 1 minus half to the power n into e of n. This is the required answer. Find the inverse z transform of x of z is equal to 8z square plus 4z divided by 4z square minus 4z plus 1 with ROC mod z is greater than half. It is given x of z is equal to 8z square plus 4z divided by 4z square minus 4z plus 1. And multiplying dividing by z to the power minus 2, we get 8 plus 4z inverse divided by 4 minus 4z inverse plus z to the power minus 2. Or if I take 4 outside, 2 minus z inverse plus 8z inverse divided by 2 minus z inverse whole square. Or 4 divided by 2 minus z inverse plus 8z inverse divided by 2 minus z inverse whole square, which is equal to 2 divided by 1 minus half z inverse plus 2z inverse divided by 1 minus half z inverse square, which is equal to 2 divided by 1 minus half z inverse plus, I'll write it as 4 into half z inverse divided by 1 minus half z inverse square. Then taking inverse z transform and referring the table, we get x of n is equal to 2 into half to the power n into u of n plus 4n into half to the power n into u of n, which is equal to 2 plus 4n into half to the power n into u of n. Find the inverse z transform of x of z is equal to z cube plus z square plus 3 by 2 z plus half divided by z cube plus 3 by 2 z square plus half z with ROC mod z is less than half using partial fraction expansion method. It is given x of z is equal to z cube plus 3z z square plus 3 by 2z plus half divided by z cube plus 3 by 2z square plus half z. Multiplying both numerator and denominator by z to the power minus 3, we get x of z is equal to 1 plus z inverse plus 3 by 2 z to the power minus 2 plus half z to the power minus 3 divided by 1 plus 3 by 2 z inverse plus half z to the power minus 2. Here m is equal to 3 and n is equal to 2. That is m naught less than n. So we have to use long division method. That is half z to the power minus 3 plus 3 by 2 z to the power minus 2 plus z inverse plus 1 should be divided by half z to the power minus 2 plus 3 by 2 z inverse plus 1. So if we multiply by z inverse, we get half z to the power minus 3 plus 3 by 2 z to the power minus 2 plus z inverse. So we'll get 1. Therefore, x of z is equal to z inverse plus 1 divided by 1 plus 3 by 2 z inverse plus half z to the power minus 2. So by considering this one as x1 of z, now we can use partial fraction for the second equation or second term. Then x1 of z is equal to 1 divided by 1 plus 3 by 2 z inverse plus half z to the power minus 2, which is equal to 1 divided by 1 plus z inverse into 1 plus half z inverse, or k1 divided by 1 plus z inverse plus k2 divided by 1 plus half z inverse, or k1 is equal to 1 plus z inverse into x1 of z at z is equal to minus 1, which is equal to 1 divided by 1 plus half z inverse at z is equal to minus 1, we get k1 as 2. Then k2 is equal to 1 plus half z inverse into x1 of z at z is equal to minus half, which is equal to 1 divided by 1 plus z inverse at z is equal to minus half, we get k2 as minus 1. Then x of z is equal to z inverse plus 2 divided by 1 plus z inverse plus minus 1 divided by 1 plus half z inverse. Since ROC is given, mod z is less than half, then x of n must be left-sided sequence. And using linearity property and referring the table and taking inverse Z transform, we get x of n is equal to delta of n minus 1 minus 2 into minus 1 to the power n into u of minus n minus 1 plus minus half to the power n into u of minus n minus 1. Therefore, x of n is equal to delta of n minus 1 plus minus half to the power n minus 2 into minus 1 to the power n into u of minus n minus 1. Find the causal signal x of n if x of z is given by x of z is equal to z to the power minus 6 plus z to the power minus 7 divided by 1 minus z inverse, which is equal to z to the power minus 6 divided by 1 minus z inverse plus z to the power minus 7 divided by 1 minus z inverse. So, by taking inverse transform, inverse Z transform and using time shift property, we get x of n is equal to u of n minus 6 plus u of n minus 7. Find the inverse Z transform of x of z is equal to 3 minus 2z inverse plus z to the power minus 2 divided by 1 minus z inverse into 1 minus 1 by 3 z inverse square with mod z is greater than 1 using partial fraction expansion method. So directly we can write x of z is equal to k1 divided by 1 minus z inverse plus gamma 1 divided by 1 minus 1 by 3 z inverse plus gamma 2 divided by 1 minus 1 by 3 z inverse whole square, or k1 is equal to 1 minus z inverse into x of z at z is equal to 1, which is equal to 3 minus 2z inverse plus z to the power minus 2 divided by 1 minus 1 by 3 z inverse whole square with z is equal to 1. So, which we will get it as 4.5. Then gamma 2 is equal to 1 divided by 2 minus 1 factorial into minus 1 by 3 to the power 2 minus 1 into d to the power 2 minus 1 divided by d of z inverse to the power 2 minus 1 into 1 minus 1 by 3 z inverse whole square into x of z at z is equal to 1 by 3, which is equal to 1 divided by minus 1 by 3 into d by dz inverse of 3 minus 2z inverse plus z to the power minus 2 divided by 1 minus z inverse at z is equal to 1 by 3, which is equal to 1.5. Then gamma 2 is equal to 1 divided by 2 minus 2 factorial into minus 1 by 3 to the power 2 minus 2 d power 2 minus 2 divided by d into z inverse of 2 minus 2 into 1 minus 1 by 3 z inverse whole square into x of z at z is equal to 1 by 3, which is equal to 3 minus 2z inverse plus z to the power minus 2 divided by 1 minus z inverse at z is equal to 1 by 3. After solving this, we get minus 3. Therefore, x of z is equal to 4.5 divided by 1 minus z inverse plus 1.5 divided by 1 minus 1 by 3 z inverse minus 3 divided by 1 minus 1 by 3 z inverse whole square. Multiplying and dividing third term by 1 by 3 z inverse, we get x of z is equal to 4.5 divided by 1 minus z inverse plus 1.5 divided by 1 minus 1 by 3 z inverse minus 3 into 1 by 3 z inverse into z to the power plus 1, that comes from the denominator, divided by 1 by 3 into 1 minus 1 by 3 z inverse to the power minus 2. Since ROC mod z is greater than 1, then x of n must be right-sided sequence. And referring the table and using time shift property to third term of above equation, we get x of n is equal to 4.5 into u of n plus 1.5 into 1 by 3 to the power n into u of n minus 9 into n plus 1 into 1 by 3 to the power n plus 1 into u of n plus 1. Determine the inverse Z transform of the following sequences using partial fraction expansion. First one, x1 of z is equal to 4 minus 3z inverse plus 3z to the power minus 2 divided by z plus 2 into z minus 3 whole square with ROC is greater than 3. Second one, x2 of z is equal to 4 minus 3z inverse plus 3z to the power minus 2 divided by z plus 2 into z minus 3 whole square with ROC is given less than 2. Third one, x3 of z is equal to 4 minus 3z inverse plus 3z to the power minus 2 divided by z plus 2 into z minus 3 whole square with mod z, where is between 2 and 3. So it is given x of z is, in all the three cases, only ROC is different. X of z is given, or I'll take x1 of z, first one, 4 minus 3z inverse plus 3z to the power minus 2 divided by z plus 2 into z minus 3 whole square, which is equal to 4 minus 3z inverse plus 3z to the power minus 2 divided by, if I take z cube out, 1 plus 2z inverse into 1 minus 3z inverse whole square will get, which is equal to z to the power minus 3 into 4 minus 3z inverse plus 3z to the power minus 2 divided by 1 plus 2z inverse into 1 minus 3z inverse whole square. I am going to consider it as xa of z. Then we can do the partial fraction for this. Xa of z is equal to k1 divided by 1 plus 2z inverse plus gamma 1 divided by 1 minus 3z inverse plus gamma 2 divided by 1 minus 3z inverse whole square, or k1 is equal to 1 plus 2z inverse into xa of z at z is equal to minus 2, which is equal to 1. Then gamma 1 is equal to 1 divided by 2 minus 1 factorial into minus 3 to the power 2 minus 1 into d 2 minus 1 divided by dz inverse of power 2 minus 1 into 1 minus 3z inverse square into xa of z. At z is equal to 3, we get the answer as 1. Similarly, gamma 2 is equal to 1 divided by 2 minus 2 factorial into minus 3 to the power 2 minus 2 into d power 2 minus 2 divided by d z inverse of 2 minus 2 into 1 minus 3z inverse square into xa of z. At z is equal to 3, we get the answer as 2, or x of z is equal to z to the power minus 3 into 1 divided by 1 plus 2z inverse plus 1 divided by 1 minus 3z inverse plus 2 divided by 1 minus 3z inverse whole square. Or rearranging the above equation, we get x of z is equal to z to the power minus 3 divided by 1 plus 2z inverse plus z to the power minus 3 divided by 1 minus 3z inverse plus 2 by 3 into z to the power minus 2 into 3z inverse divided by 1 minus 3z inverse whole square. So in all the three problems, expression is same, only the ROC is different. So for the first case, it is given ROC mod z is greater than 3. That means x of n must be right-sided. And referring the table and using time shift property, we get x of n is equal to minus 2 to the power n minus 3 into u of n minus 3 plus 3 to the power n minus 3 into u of n minus 3 plus 2 by 3 into n minus 2 into 3 power n minus 2 into u of n minus 2. For the second case, it is given ROC mod z is less than 2. That means x of n must be left sided. And referring the table, and once again we have to use time shift property. We get x of n is equal to minus of minus 2 to the power n minus 3 into u of minus n plus 2 minus 3 to the power n minus 3 into u of minus n plus 2 minus 2 by 3 into n minus 2 into 3 power n minus 2 into u of minus n plus 1. And for the third case, it is given ROC is between 2 and 3. Then x of n must be two-sided. And referring the table and using time shift property, we get x of n is equal to minus 2 to the power n minus 3 into u of n minus 3 minus 3 to the power n minus 3 into u of minus n plus 2 minus 2 by 3 into n minus 2 into 3 to the power n minus 2 into u of minus n plus 1. Now we are going to discuss some of the problems on power series expansion method. First one, find the inverse Z transform of x of z is equal to 1 divided by 1 minus 1.5 z inverse plus 0.5 z to the power minus 2 with mod z is greater than 1. Since the ROC is outside the circle of radius 1 in the z plane, the x of n must be right-sided. Therefore, x of z we have to convert it into power series having the one negative powers of z. That is, in the numerator we have 1 minus 1.5 z inverse plus 0.5 z to the power minus 2. Then we have to multiply it by 1, we will get 1 minus 1.5 z inverse plus 0.5 z to the power minus 2 or 1.5 z inverse minus 0.5 z to the power minus 2. So once again I have to multiply it by 1.5 z inverse. We will get 1.5 z inverse minus 2.25 z to the power minus 2 plus 0.75 into z to the power minus 3. Which is equal to, this is the continuation, 1 plus 1.5 z inverse we have 1.75 z to the power minus 2 minus 0.75 z to the power minus 3. So once again I have to multiply by 1.75 z to the power minus 2. We will get 1.75 z to the power minus 2 minus 2.75 625 z to the power minus 3 plus 0.875 z to the power minus 4. 1.875 z to the power minus 3 minus 0.875 z to the power minus 4. Once again I have to multiply by 1.875 z to the power minus 3. So I will get 1.875 z to the power minus 3 minus 2.8125 z to the power minus 4 plus 0.9375 z to the power minus 5. So remaining term is 1.9375 z to the power minus 4 minus 0.9375 z to the power minus 5. So once again it is 1.9375 z to the power minus 4. So it will be 1.9375 z to the power minus 4 minus 2.906 z to the power minus 5 plus 0.96875 z to the power minus 6. So we can keep on dividing this and we will get some terms. So I can write x of z as 1 plus 1.5 z inverse plus 1.75 z to the power minus 2 plus 1.875 z to the power minus 3 plus 1.9375 into z to the power minus 4 plus so on. So comparing this equation with the power series expansion equation, we get x of n is 0 for n less than 0 and x of 0 is 1, x of 1 is 1.5, x of 2 is 1.75, x of 3 is 1.875, x of 4 is 1.9375 and so on. So I can write x of n as x of n is equal to, this is the origin 0 position, 1, 1.5, 1.75, 1.875, 1.9375, so on. Next problem, find the inverse Z transform of x of z is equal to 1 divided by 1 minus z to the power minus 2 with mod z is less than 1. Since ROC is given, mod z is less than 1, the signal is left sided, or x of z is equal to 1 divided by 1 minus z to the power minus 2, which is equal to z square divided by z square minus 1, or I can write it as minus z square into 1 divided by 1 minus z square, which is equal to minus z square into summation k is equal to 0 to infinity z square to the power k, which is equal to minus summation k is equal to 0 to infinity z power 2 into k plus 1, and taking inverse z transform, we get x of n is equal to minus summation k is equal to 0 to infinity delta of n plus 2 into k plus 1 is the answer. A causal signal x of n has z transform x of z is equal to cos Z inverse. Find x of 3 and x of 8. We know that cos theta is equal to 1 minus theta square divided by 2 factorial plus theta to the power 4 divided by 4 factorial plus theta to the power 6 divided by 6 factorial plus theta to the power 8 divided by 8 factorial plus so on. So it is minus, not plus, minus. Therefore, x of z is equal to cos of z inverse, which is equal to 1 minus z to the power minus 2 divided by 2 factorial plus z to the power minus 4 divided by 4 factorial minus z to the power minus 6 divided by 6 factorial plus z to the power minus 8 divided by 8 factorial plus so on. Then comparing this equation with the power series expansion equation, we get x of 3 is equal to 0, there is no term, and x of 8 is equal to 1 divided by 8 factorial, which is equal to 1 divided by 40,320. A causal signal x of n has z transform x of z is equal to sine z inverse into 1 plus 3 z to the power minus 2 plus 2 z to the power minus 4. Find x of 11. It is given x of z is equal to z inverse minus z to the power minus 3 divided by 3 factorial plus z to the power minus 5 divided by 5 factorial minus odd numbers we have to take z to the power minus 7 divided by 7 factorial plus z to the power minus 9 divided by 9 factorial minus z to the power minus 11 divided by 11 factorial plus so on into 1 plus 3 z to the power minus 2 plus 2 z to the power minus 4. We have x of z is equal to summation n is equal to minus infinity to infinity x of n into z to the power minus n. Since the given signal is causal, then x of z is equal to summation n is equal to 0 to infinity x of n into z to the power minus n, which is equal to x of 0 plus x of 1 into z inverse plus x of 2 into z to the power minus 2 plus so on x of 11 into z to the power minus 11 plus so on plus x of infinity into z to the power minus infinity. Therefore, the coefficients of z minus 11 is x of 11. So, from x of z we get x of 11 is equal to minus 1 divided by 11 factorial plus 3 divided by 9 factorial minus 2 by 7 factorial, which is equal to minus 3.88 into 10 to the power minus 4. Find the inverse Z transform of x of z is equal to sin z with ROC mod z is greater than 0. We have sin theta is equal to theta minus theta cube divided by 3 factorial plus theta to the power 5 divided by 5 factorial minus theta to the power 7 divided by 7 factorial plus so on. Then x of z is sin z, which is equal to z minus z cube by 3 factorial plus z to the power 5 divided by 5 factorial minus z to the power 7 divided by 7 factorial plus so on. Which one we can write it as summation k is equal to 0 to infinity minus 1 to the power k into z to the power 2k plus 1 divided by 2k plus 1 factorial. Taking inverse z transform, we get x of n is equal to summation k is equal to 0 to infinity minus 1 to the power k divided by 2k plus 1 factorial into delta of n plus 2k plus 1. Next problem, find the inverse z transform of x of z is equal to e power z with ROC all z except mod z is equal to infinity. We have e power theta is equal to 1 plus theta square divided by 2 factorial plus theta cube divided by 3 factorial plus theta to the power 4 divided by 4 factorial plus so on, which is equal to summation k is equal to 0 to infinity theta to the power k divided by k factorial. Then x of z is equal to e power z, which is equal to summation k is equal to 0 to infinity z to the power k divided by k factorial, which is equal to summation k is equal to minus infinity to 0. I can write z to the power minus k divided by minus k factorial, or summation k is equal to minus infinity to infinity 1 divided by minus k factorial into u of minus k into z to the power minus k. Comparing with x of z equal to summation n is equal to minus infinity to infinity x of n into z to the power minus n, we get x of n is equal to 1 divided by minus n factorial into u of minus n. Using power series expansion method, determine inverse z transform of x of z is equal to cos of 2z with mod z is less than infinity. It is given x of z is equal to cos of 2z and the corresponding x of n must be left sided sequence because ROC is less than infinity. It is left sided sequence. We know that cos theta is equal to 1 minus theta square divided by 2 factorial plus theta to the power 4 divided by 4 factorial minus theta to the power 6 divided by 6 factorial plus so on. Or we can write cos theta is equal to summation k is equal to 0 to infinity minus 1 to the power k into theta to the power 2k divided by 2k factorial. Then x of z given cos of 2z, which is equal to summation k is equal to 0 to infinity minus 1 to the power k into 2z to the power 2k divided by 2k factorial, which is equal to summation k is equal to 0 to infinity minus 1 to the power k 2 to the power 2k into z to the power 2k divided by 2k factorial, or summation k is equal to 0 to infinity minus 4 to the power k into z to the power 2k divided by 2k factorial, and taking inverse z transform, we get x of n is equal to summation k is equal to 0 to infinity minus 4 to the power k divided by 2k factorial into delta of n plus 2k. Using power series expansion method, determine the inverse z transform of x of z is equal to ln of 1 plus z inverse with mod z greater than 0. It is given x of z is ln of 1 plus z inverse and the corresponding x of n must be right sided because it is given is greater than 0. And we know that ln of 1 plus theta is equal to theta minus theta square divided by 2 plus theta cube divided by 3 minus theta to the power 4 divided by 4 plus so on if mod theta is less than 1, which is equal to summation k is equal to 1 to infinity minus 1 to the power k minus 1 into theta to the power k divided by k, or x of z is equal to ln of 1 plus z inverse, which is equal to summation k is equal to 1 to infinity minus 1 to the power k minus 1 into z inverse to the power k divided by k, with mod z inverse is less than 1, that is mod z is greater than 1, which is equal to summation k is equal to 1 to infinity minus 1 to the power k minus 1 into z to the power minus k divided by k. Then taking inverse z transform on both sides, we get x of n is equal to summation k is equal to 1 to infinity minus 1 to the power k minus 1 divided by k into delta of n minus k.